Welcome back. In this video, we'll take a look at more sine and cosine functions and find their equation from their graph. In number 4, we're going to specifically work on writing this function as a sine function. So let's dive into this graph and then find its properties with knowing a sine function base. So if I'm working with a sine function, I know that a sine function starts at the midline and ends at the midline with a full cycle. So I'm going to consider the starting point on this graph to be x equals 1 and the ending point to be x equals 3. That will be one full cycle of sine from this point to point at 3. So there's really 2 units there to create a full cycle of sine. So let's consider the attributes of this sine function. Starting with the amplitude, we can see that the midline here is just at 0, so our amplitude goes up to 5 and down to negative 5. There we go. So we have an A value of 5 amplitude. If I consider the period, we just said that there's 2 units that we go through, 2 units of length. So our period is equal to 2. And so our B value, if period is equal to 2, then that means 2 is equal to 2 pi over B. And so that would force B to be equal to pi. So B has to be pi in this equation. So in other words, we're going through pi cycles. So if I consider the phase shift next, our phase shift, we've actually shifted to the right 1 unit. I've shifted over to the right 1 unit. So when I consider my phase shift, I've gone to the right 1 unit. And it looks like there's no vertical shift because our midline is y equals 0. So 0 or none on the vertical shift. So let's consider this again as a sine function. We can say that this is y is equal to, our amplitude is 5. So we increase and then decrease amplitude of 5. Sine of, our B value is going to be pi. So we have a pi as the B value, and then we'll have x. And since I shifted right 1 unit, I'll have a minus 1, x minus 1 inside the parenthesis there. And then we'll finish it off with an outer parenthesis. So this full function as a sine function is y is equal to 5 sine of pi times x minus 1. So we have our vertical shift, or sorry, our horizontal shift or our phase shift is 1, and the B value is going to be pi. So there's our equation for this one. Let's take a look at the next question, number 5. Number 5 here, we will write here as just a cosine function. So if I wanted to write this as a cosine function, if I start here and end here, that looks like a cosine function, starting at its amplitude and ending at the amplitude. Again, notice that this is going to have a y equals 1 as our midline, or y equals 0 as our midline, so the vertical shift has no vertical shift. Our amplitude A, we notice that the absolute value of A here is going to be 2, but we'll notice that we start at -2, so when we look at the actual A value for this equation, we'll find that to be -2, because we start our graph there for that cosine function. The period we can solve for next. Notice that the period is going to be 2 units. So very similar to our last question, we have a period of 2 units. So if the period is 2 units, we saw before that the b value is going to be pi when our period is 2 units. So again, you can take a look at that last example again if you'd like to see why that is true, but a period of 2 will give us a b value of pi. And in this case, there will be no vertical shift. There will be none for that vertical shift because we're starting at x equals 0 for this. Okay, so if I put this together, this equation, we can say, again, we're going to have an a value in front as -2 because that's our starting point. Cosine function. And then our b value is going to be pi times x. And there's no phase shift or vertical shift, so we'll leave it like this. So 2 cosine pi times x. And that is the complete solution for number 5. We'll try one more out here. And again, we'll work with the cosine function since they only give us this little portion of the graph. We'll again go with a cosine base. Notice that we start at -pi/4, end at 3pi/4. And again, the midline looks to be just y equals 1 again. So we have a midline, y equals 0, y equals 0. Our amplitude here, absolute value of A is 3, and notice that we start our graph, we'll consider starting our graph here at 3. And so our A value in this equation is going to be 3. The period, let's consider the period for one moment. When we start and where we finish, this is going to be a full pi units from where we start and finish our complete cycle. So the period here is equal to pi, meaning my b value is going to be 2 because we can make 2 cycles in a full 2 pi and a single cycle in only pi units. If I consider the phase shift on this, I'm going starting at -pi/4, so I'm going pi/4 to the left when I go to my phase shift, because that's my phase shift starting point, -pi/4. And if we consider a vertical shift, since our midline is at 0, we would have no vertical shift. So let's consider now putting these pieces of information together to write an equation. We'll start with the y is equal to, our amplitude is going to be 3, a is 3. We'll start with our cosine function. We have a b value that's going to be equal to 2 based on our period. And then I'll do a parenthesis x. And here, since I'm going to the left, pi/4 units, I'm going to do a plus pi/4. And that parenthesis. And again, I'll just have a plus 0 on the end because of a vertical shift of 0 or a midline of 0. So I can leave that off. We certainly can distribute this 2 into the rest of our equations. So an alternative way we could write this equation, we could say is y is equal to 3 cosine of 2x, and then we could say plus pi over 2. So both ways are acceptable to write that equation. It's a little bit easier to write this version first with the b value out and the phase shift inside. But either way will work in more. So hope this is helpful when trying to identify graphs of functions with either the sine or cosine function. Look forward to seeing you in the next video. If you'd like to see these examples again, I encourage you guys to go through them again until you're confident with kind of the properties of these graphs and what to look for. So thanks for watching.